Many developers get lost in the hype of object-oriented design. They miss out on how expressive and succinct their code could be if they tried functional programming. Who knows what monads are? No, it's not a typo. It's by no means nomads in the desert. Someone once wrote that it's something that is impossible to describe to anyone who doesn't already know what one is. We're chattering away here, and Chris is having a blast, because he perfectly knows what monads are and has already taken pole position to explain them to us. As he said himself, we'll gain a clear and simple understanding of monads and how they can help us refactor our code to be clear and concise. Okay, let's do it. Ladies and gentlemen, Chris Pitt on the stage.
Hi, can you hear me? Good? Okay. When I count to 3, I'd like you to shout, slow down. So 1, 2, 3? Okay, 1, 2, 3? All right. I predominantly deal with English first language folks, so I forget sometimes to speak slowly and clearly. And if at all I'm rushing or unclear, feel free to shout slow down or ask a question. Welcome to this talk. It's been ages since I've spoken about this, and I think it's pretty fun. I'm Chris, and before I get too deeply into it, I would like to thank a few people. So firstly, thank you to the organizers of the conference. I've had a blast today and yesterday. I'm sure you've enjoyed the talks today, and I'm overjoyed to be here and for them to make that possible. Also, I want to thank the people that I work for, because they gave me time to do this and they paid some of the travel for me to be here. So thank you to them when they're watching this at home. Hi, Mom. Okay. This is based on the work of a Ruby on Rails developer named Tom Stewart. He's a really, really fun dude to listen to. And if you want to sample a bit more of his work, he actually has written quite an awesome book called Understanding Computation. It's one of my favorite tech books, actually, and it goes from explaining computation all the way from the early days of the first computers to even making a compiler in code. It's a really good read, so I recommend this. Okay, right at the top, if there's one thing that I want you to remember after this talk, it's that monads are an ordinary data type. If that's all you get from this, I want you to be able to understand they're an ordinary data type, and hopefully with the examples and the explanations, you will get there, and also come to realize that you're probably already using them. So let's figure out why that is. I got a question. Could we maybe pass the mic around if someone feels like answering this? What is a stack? How would you define a stack? Anyone want to take a stab at that? Oh, I'm going to have water while I wait for someone to be brave enough. It is a data structure. Yeah, it's a data structure. I mean, there we go. Thank you. It has some common semantics. The name stack actually comes from this idea in restaurants where they have this tube and there's a spring at the bottom and they push a whole stack of plates down. So the plates you stick in there first are the ones you get out last, and then someone at some point does a whole bunch of dishwashing, puts all the plates back in there. That's how you can think of a stack's data structure. So what goes in first comes out last. You only really ever get to see what's on top until you take that thing off. A stack has operations and rules that help you to understand that it is a stack. Those operations and rules are kind of tightly linked, as you're about to see. For instance, if we have some mythical stack implementation in PHP, we should be able to do these operations to it. We should be able to push a value onto it, onto the top of it. We should be able to see what the top value is. We should be able to just get rid of the top value so we can see what's underneath it. And we need to know if it's empty or not. We can't, for instance, get the top value or look at the top value if it's empty because there's no top value. Anyway, these 4 operations, and they express themselves in a bunch of rules. If we push a value onto the stack, the top value should be that value we just pushed on. If we pop something off, it should be just like it was before we pushed the value on, and so forth. Nice little note about PHP 8.4 where we can avoid the brackets around the new class constructor. But no further code in this talk actually uses that, so I'm kind of sad about that. Okay. Knowing the operations and the rules, we can implement a stack however we like. We could, say for example, make an array stack. Just accepts an optional array of items. There's a way to push values onto it in a way that makes this kind of immutable, right? We're getting a new stack every time we push an option onto it. We should be able to see what the top item is. Shout out to what I said earlier about not being able to see the top thing if there isn't anything there. It didn't feel right for me to return null in this sense, because what if you push null onto the stack, right? Anyway, we should be able to see what the top item is, and we should be able to get rid of the top item so that we can see the stuff underneath, or tell if the stack is empty. That's one implementation of a stack, an array stack. What about a linked list stack? Linked list is kind of like a weird structure where you only really care about the first item called the head, and then everything else goes in this thing called the tail, and it kind of links between head and tail. Anyway, not really important. We should be able to push a value onto it, which will put the current linked list stack in the tail, and put the value we've just pushed onto it in the head. We should see what the top thing is, which is just the head value. Oh, I've got a syntax error here. There should be this arrowhead. We should be able to pop the head value off and just get the rest of the things, which essentially is the same as returning the tail. And if it's empty, well, is the tail empty? There's no way that we can push an item onto this linked list stack without having something in tail, another linked list stack in tail. So this is a fairly reasonable way to see if it's empty or not. Okay. Two implementations of a stack that have the same operations and rules. And given that, we can define some new operations because we know what they're like. We know what both of these stacks are capable of doing, so we can make some new functionality for it. Say, instead of just knowing whether it's empty or not, we want to tell how big the stack is, how many things are on it. We know that we have access to an isEmpty method. We know that we have access to a pop method, and so using this kind of recursive code, we can figure out what the size of the stack is. Because pop and push return new stacks the whole time, doing this, popping something off and checking the size, isn't going to modify the original stack, so it's fairly safe for us to do. And note to self, if you are wanting to implement a trait that requires the methods that you are using in that trait method, then you can declare the methods that you are going to use as abstract. And then everything that uses this trait must implement those methods with the same signature. So it's kind of like a way of saying, this trait can only be used in something that looks to me like a stack. Okay. So stack becomes a specification, right? We've got those 4 operations we need to do. We can implement however we want, but it has to implement that. And given the specification, we can use the common interface to derive new functionality, like our size method. What's a collection? This one's a little bit easier, and it's very specific to this use case. But if you think about a collection, what kinds of things do you commonly do with it? What's a kind of behavior that you would expect to see on a collection? Right, iterate over it. So I'm going to define the operations and the rules for this specifically like that, right? The only operation that I expect in this case is that I can make a collection with an optional array of items, and that I can run a closure for each item. Okay, cool. So how could we implement this, knowing that we have to obey those operations and rules? We can expect our optional array of items. We can have an each function that just loops over each item in the items property, and then we run that closure on each of them. Being sure to return this. I think at this point we're not really concerned about mutation inside items, so it's okay to not have to do a new self here, but your mileage may vary. We can create a new instance of the array collection with some items, and on each of them, if we var dump, we're just going to get this response in the terminal. Another interesting way of implementing a collection for these operations and rules is a range collection. You've probably seen or used PHP's built-in range function, and I think it is magical and wonderful. But if we had to implement our own collection that has this each operation, then we could take in the start and the end and the optional step, just like the built-in range function. And when this each method is run with the closure, we can just create that array by using the arrange function. It's very similar. The rest of the code's pretty much the same. But this adheres to the same operations and rules that we defined for our array collection. We can make a new collection. We can run each. If we put 1 and 3 in here, we would actually get exactly the same output as our array collection in the previous slide. So we can, again, define more operations because we know what a collection looks like to us. Say we wanted a way to filter the items in it and return an array of them. We could start our array here, run the each function. If the response of this filter item is truthy, we can add that into our array. You get it, right? We also need to ensure that this is only used by something that looks to us like a collection. But here we've derived a new function because we know that the each method exists. Okay, so in this case, collection is also a specification. We know what the operations are, we know what the rules are, and we can make new stuff because of the common interface. Okay, so to summarize, what are stack and collection? They're just abstract data types. We can define what the operations are and their rules are, and that's the same for any abstract data type that we've got. We know what the operations are of a string or a number in our PHP code. It's maybe not as succinct as these two data types that I've shown you now, but we know what we can do with a string or with a number, with a float, with a Boolean in PHP, because it's also an abstract data type. So let's look at a little bit of code. Live coding. Please be gentle to me. Okay. I've prepared some examples to have a little dig into what it looks like to make and use monads. Say we're diving into a legacy code base. We can't use modern PHP stuff in this code base. It's stuck in like PHP version 6. And we have to deal with the problem of null references in our code base. So we've got a country class, a province class, and a city class. And country and province can have child items. And so we can create this kind of association when we define our city and our province and our country. And we've got this little helper function that someone wrote years ago, which gets the city from a country that is passed in. If in the ideal scenario, everything is set up correctly, and we run this, clear PHP1, then we should see the city because we've passed in the country and all of those relationships are well defined and yada yada. But what happens when a bad developer who's no longer with the company forgot to do the relationship? We have a problem, right? We're looking up city when the province is null in the country because that relationship was not set up. Now, in modern PHP, we could probably do something like this, and that would be really cool and save us a lot of time and headache, and we wouldn't have to use a monad here. We would avoid the problem, still not getting the ideal scenario of our full relationship, but we wouldn't have an exception thrown. However, because we're on a very old version of PHP, we have to make another plan, and I think we can do this by using a monad. So in this example only, I'm going to write it from scratch because it's kind of a simple one. We can make a thing, I'll call it maybe, and this thing can wrap our values and do this kind of careful property-defined checking for us so that we're not given exceptions when someone hasn't defined this relationship properly. Let's make a private value property. Again, we can't do any fancy type hitting because very old PHP version, but we can make a constructor. Oh, that was really misspelled. Construct, and this can take in a value, but let's say that by default it's allowed to be null, and then because we can't do property promotion here, we'll just have to set this inside the constructor. Okay, so this deals with wrapping the value. How about getting the relationship values in a safe way? What if we make a function called then that just takes the name of the thing that we are trying to get, and if is set this value, which remember is this thing that we wrapped up, has that property, then let's return that. But let's return it wrapped. Return new, wrapped in another instance of maybe. And finally, once we've done like a whole bunch of wrapping and calculations here and hopefully safe, not null checking, we also need a way to get the internal value out. Maybe we just make a value function that returns this value. I haven't handled the case for where this isn't defined. So what I'm going to do in this case, if the property is null, is I'm just going to return a new instance, return a new instance of this monad. Okay, so how do we start to use this? This helper function that was written so long ago, maybe we can say new maybe. And then here we have to start using this then method, just to make it a little safe to do our lookups. And maybe we unwrap the value at the end. Okay, let's see if this works. Oh, I've got an error here. It's because I'm using an old version of PHP and it doesn't have that cool new PHP 8.4 feature. Okay, if we run this, we get our city. This is the happy path, right? But that's because all the relationships are defined. What about when one of those relationships is not defined? Well, no exception. This is the same as if we use the null property check syntax from more modern PHP. So, okay, that avoids the problem. We have written like a whole bunch of code here. Up to you whether you think that this would be a good approach for a legacy application. Maybe we can optimize this a little more. I don't really like that I'm using then here so often. What if we define a magic method? Function get. And this just takes the name of the property that we're trying to get and returns this then name. So now in our helper function, we can get rid of the then calls. Does it work? Yes, it does. I think the only other optimization that I would think about here is trying to expand our monad out into the wider system to get our system to understand what a maybe is and use it more often. If we accepted, instead of a country here, we accepted a maybe and returned a maybe, then we wouldn't need to wrap this. And we wouldn't need to unwrap it here. I mean, we would need to do this somewhere else in the system, so probably here, right? Nope, on the outside here. Now what do we've got? It's the same thing again. Okay, so the more our system understands what this maybe monad is, the less we have to do this deep in the code, and we kind of just do it where we define things or where we eventually want their value, like over here. That's pretty cool. We can actually also chain this, but I don't want to do that right now. Anyway, that's the first example, right? This is a monad called maybe. Sometimes it's called optional. Some frameworks actually have an implementation of this that's called optional. I think Laravel does at the moment. And it's a useful way of dealing with null values, potentially, null value references. Okay, let's look at another example. Less making monads from scratch in this one. I have a more modern project, because you can see I'm using property type promotion, and property type promotion, class, property, constructor, whatever it's called. You get the point. It's got a genre class, and each genre has an array of authors, and each author has an array of books, and each book has a string of content. And my boss has asked me for the weirdest report ever. He wants to know every single word in any given array of genres. It's a weird request, I know, but hey man, he pays the bills. So let's try and make this work. I've gone to Stack Overflow and found nice flat map implementation in PHP. Actually, I really like the syntax of this. Cool. And then I made this really ugly helper method. It flat maps over all the genres in a given array. And for each genre, it flat maps over that genre's authors. And for each author, it flat maps over that author's books. And finally, for each book, it explodes the content and then trims each word. So when we run this, it is actually doing the thing that the boss has asked it to do. I mean, he's also asked for some charts and stuff. I don't really care about that. By the way, none of this code will pass PHP Stan's strict rules. I'm so sorry, Dad. But it's fun code to write. So what do we do from this point? What if we want to get away from this really ugly sideways pyramid? We could try and implement another monad. I've got one right here for this occasion. So I'll leave some of the code commented out, but this one looks pretty similar to before. We have some kind of value that we're wrapping. In this case, it's an array of things. We have a then function which returns a new instance of this monad, but it also does something extra. In this case, it flat maps over the decorated value and runs a mapper closure with it. And we have a way to unwrap this value at the end. So instead of running this heaping, steaming pile of code, we can run a slightly less heaping, steaming pile of code that wraps our array of genres in an instance of this monad and calls a bunch of then functions on it. For some reason, I decided not to put the trimming in this code example, and I hate myself for it. So now our function should still work. Okay, cool. Less ugly than before, a little bit more complex, but I think we can do better than this. I think there is another optimization we can do. Again, favoring the ever dirty magical __ get method. So all we need to do here is call this then again, but we can just resolve the thing that we're trying to look up, right? The property we're trying to look up. So instead of this, we can now type this. Trimming's still not there. I'm so disappointed in you, Chris. Okay, now we're trimming the content. We can't really avoid this then call because it's not an array that we're dealing with, it's a string variable. But we have a little bit of higher order magic going on here. So we wrap our genres in this many monad. We can reference the authors array and then the books array, and it's just doing its flat map thing behind the scenes on its own until we get to the point where we need to figure out what to do with the resulting books. And so for each book here, we're exploding on content and trimming the word, and we unwrap it right at the end. So this should work. Let me run it again in terminal. Yes, it does. Okay. Like we saw with the maybe monad, if our wider system starts to understand monads and doesn't just deal with these stinking simple data types, we could maybe say many is returned from here so that we don't have to wrap this. Maybe. We could do that if we want to. But this is pretty good, right? This code compared to this really ugly code up here. And it's doing something vastly more complex than just null checking a property. That's pretty cool. All right, last example. Say we've got this class that we're trying to configure our brand new shiny application with. We do things like set the app name or the time zone or some cryptographic hash key if we want to. I'm kind of a fan of this kind of getter, setter, combined method. Not everybody is, I understand, but I like the pattern here. If I pass in a value, it's got to set that value. If I don't pass in a value, it's just got to return whatever it had before. Pretty common in a lot of PHP applications and frameworks. I kind of like the pattern. But every time I add a new config value, I'm making a property here, and then I'm making a new function underneath here. It's like ever expands. I'm not happy about this. I could make a magical __ call method, take these out, and then, oh man, you know what? I should actually run this code first so that you can see that it's actually working. I think that would be better. So, where I create an instance of this, I'll just scroll down to. I make a new config. I call my fluent getter setter method with a value. Both of them, in fact. Config is sorted, right? But I don't want to have to keep on making a new fluent method every time I want to set these values on this class. So instead, I'm going to make an __ call method. This has essentially the same code. It's still checking if the property exists or if the value is null. But, you know, this actually is wrong. This should be checking parameters 0. Whatever. Is set something like parameters 0. But it's essentially doing the same thing, right? If this is not set, then just return the value. Otherwise, set the value and eventually return the same kind of thing, the same type of monad. This should actually still work, so I'm going to run it again to make sure. Okay, it does. I don't have these fluent methods enabled anymore. PHP doesn't really know about them, but I do have this magical __ call method. Come to find, I start to get a lot of these types of classes in my project, and now I'm repeating this method everywhere, or worse, making a trait for this __ call method. I don't really like that solution enough. I would prefer if I could decorate the things that I want to be able to interact with fluently, and I can do that with a new monad. So, what does my new monad do? It decorates a thing. In this case, it's going to be an instance of the config class. And it has its own then method. Now, this is really funky code over here. And the reason for this is that maybe I'm trying to set private things on the decorated class, and I could do that with a lot of reflection code, or I could just do that with closure binding, which is the option I've chosen. Super dangerous. Don't actually do this in code, but you're welcome to. Just don't say I told you to. And then there's a way to unwrap the value again. So now instead of creating the config class directly, I can create a new instance of the config class and immediately wrap it in Fluent, and then I can set some stuff on it, right? This should work. Does it work? Okay. It's a little bit different because the config class is actually still wrapped in Fluent. I could then unwrap this, like if I said config value, for example, then the output should be exactly the same as it was before. Okay, but I think we can do one better, and that one better is using underscore underscore call in our monad. So this lets us, instead of doing then property name value, it lets us just call those methods as if they actually existed on our config class. So this should still work. Let's have a look. Yes, it does. And because of how we're returning the same instance of the monad, we can actually also do this as well. So we can do a little bit of formatting here. It should still work fine. Yay. Okay, we've now made our Fluent monad, and we can decorate any class that has any properties that we want to set with special getter setter things that I like, but without having to modify this original class very much. We could also use this for classes in third-party code that we can't modify or patch, and that lets us follow a same pattern in our code without modifying the original classes. I think that's kind of handy. So, the maybe and the many and the Fluent things that we just made are monads. And there's a pattern here you should have picked up while seeing all of that code. They're abstract data types, monads in general now, and they follow this pattern. You can make a new instance of them with something. You can call then and get back the same kind of monad. And you can unwrap it to get the original type that you had. Their then function signatures might look a little bit different, but the structure of them is the same. Monads are an abstract data type that follow this ability to call then and chain method calls, essentially. They're a way of repeating stuff. So how are we already using this? Where are you using this in your code or have used this in the past? Hands up if you have used JavaScript promises, or if you've used the fetch function, or the Axios JavaScript library, or kind of anything in JavaScript where you have a then method. You might be familiar with this. There is a built-in function in browsers called fetch these days, and it returns a promise, and you can call then on that. And you can return a promise inside of that closure, and then you can call then on that, getting the result of that eventual promise. It's actually really fun code. And this is also the underpinning for how things like async and await work. They're just a bit of syntactic sugar on top of promises. What about jQuery? Hands up if you use this. Yeah, you guys are old. I've used it as well, though, so we're all betraying our age here. jQuery, if you're unfamiliar or like less than 40 years old, is a way of getting a list of DOM nodes and then making some kind of mutation to them. So here we're getting all the block quotes on a page, setting the CSS color to some kind of gray, and then getting image children and setting their margin top. This is the kind of thing that you do with jQuery. It's a monadic way of finding and modifying DOM nodes. What about Laravel? Anyone here use Laravel? More of a symphony conference here, isn't this? It's fine. You've probably seen ORMs that use this kind of approach. In particular, I want to talk about the query builder in Laravel. And the way that you see this typically used in ORMs, or in Eloquent in this case, is that you can create a query, and then you can start to tack on little bits of SQL logic based on methods that you call. So here we want to get all the books that includes their author and their images, where their author name is my name, and order by publish date. Some of these translate almost directly into SQL, like where and order by and limit. Some of them a little bit more esoteric, like with, which is actually doing eager loading behind the scenes, and get, which is actually executing the query. But you get the gist of what this is doing, right? This is generating SQL in a very fluent syntax. And until you call get or first or methods like them, you're just tacking on more stuff in SQL. It's a configuration object, just like we built with the fluent monad. So monads are good for repeated operations. In the case of maybe, it was repeated null checking. We had then, and then we did our underscore underscore get, but essentially it was doing null checking for us in a repeated way. Many was a repeated flat map, where we would ask for a property, and then it would get that and map it with something and give us like a single dimensional array. That's what many was doing. Fluent was repeated configuration. Apart from Query Builder or what you might find in ORMs that have this pattern, Laravel actually has a class called Fluent that does exactly the code that I showed you could enable making this monad. They have this Fluent monad directly in code. Promises are repeated operations on future values. Promises don't just apply to the response of a fetch, but they apply to anything that returns a promise in JavaScript, like unserializing JSON from a response. jQuery was repeated filtering and mutating of elements in the DOM. Such an OG. I love jQuery. And Query Builder, like we saw from Eloquent, or from any kind of ORM that has this concept in it, is a way of repeatedly building onto a SQL query until we execute it. So, when you see yourself repeating operations, like what we did with null checking or flat mapping or any of that kind of thing, maybe ask yourself whether you might have a better time making a monad out of that repeated operation. You'll need to observe the same operations and rules, like you have a then method, and when you call it, you get back your same monad type. But if you can wrap your functionality in this concept, it actually becomes quite functional, quite succinct, quite good to look at. You get the idea. And also tell your friends about it, because now you understand what a monad is, right? This whole 30 minutes of talk, about there, 35 minutes of talk, has hopefully given you a sense of what a monad is. It's not some kind of dry mathematical abstract thing that you can only use in Scala. You can actually use this in PHP and in JavaScript. You probably use it already, you just didn't have a name for it until now. This is a monad. You can tell your friends when you see the code, I say friends, you can tell your colleagues when you see the code they're writing that, hey, maybe you could do this in a monad instead. You can teach them as well. Oh, by the way, I forgot to say, those code examples that I did, if you want to actually get to the starting state of them and follow along, because this talk video is going to be up on YouTube, you can go there. There is a GitHub gist of it, and it's got all three of those starting points, and so you can actually code along to make that, to make those monads. I'll wait till the photos stop. Okay, you can ask me afterwards if you didn't get a snap of this, or you can check it out on the video, because now it's committed to YouTube for eternity. Also, different QR code if you want to give me feedback on what you heard here today, or tell me what you would improve about it. While this is up, because you may still be doing the other link, I would like to take some questions.
Thank you for the talk first, and I have a question about the last example. I'm very old, so I used to call the thing that you show method chaining in CodeIgniter. So is this basically, I was using monads back then with CodeIgniter, or?
I think so. I think there are a lot of things that are or almost are monads, and they're just missing maybe a little bit of strictness around what they return. So if those chaining methods return something other than the type that you originally called them on, not technically a monad, but if it works like a monad, you can think of it like a monad. The idea is to treat monads like an abstract data type, just like you would think about the functions of a string or what you could do with a string, and then to try and compose their functionality to help you write better code or, yeah, better code.
So I've seen a lot of magic method calls. What about the typing? I feel that we lose the types of the variables.
Yes, that is a concern. You don't really need to do the magic method calls to have the monads. They're just a little bit of syntactic sugar on top. Just like you don't need async and await to use promises. It's just syntactic sugar on top of promises in JavaScript. So you can do it without. There are also ways that you can have type hints while using the magic methods, right? There's IDE tools you can use. There's doc type hints that you can do. You can still have the types and use the magic methods, but you don't have to use the magic methods at all if you'd rather avoid any of that. Okay, thank you very much. You can find slides here, and the video will be uploaded in a couple months.